A modern aircraft carrier can run for more than 25 years without ever refueling its reactor. A nuclear submarine can make its own drinking water, its own oxygen, and enough power to sail around the entire planet without ever coming up for air. Back in 1960, one American submarine did exactly that. All the way around the world, underwater, in a little over 60 days. And it surfaced only once the whole trip. So, on paper, these ships could stay out there almost forever. But none of them do. They all come home within a few months. And the reason comes down to something almost embarrassingly ordinary. Ask around, and you'll usually get the same answer you're probably thinking right now. The ship runs out of fuel. For thousands of years, that was exactly right. But the ships we're talking about today stopped playing by that rule more than half a century ago. So if fuel isn't the wall anymore, something else has to be. There are really only 4 things that can force a ship like this back to shore. It's fuel, it's fresh water and breathable air, it's food, and the people standing on the deck. Engineers solved the first 3. The 4th one still wins every single time. So let's start with the one almost everybody gets wrong. For most of naval history, fuel was the entire story. A sailing ship was at the mercy of the wind. A coal-burning warship could only go as far as the coal stuffed into its bunkers, and when those ran dry, it had to limp into port or beg fuel off another ship. Then oil replaced coal, which helped, but the basic problem stayed the same. Burn fuel, run out, go home. Every ship on Earth lived and died by how much energy it could carry with it. Nuclear power tore that rule up. This is the part that's hard to wrap your head around. The reactor inside a modern American carrier doesn't sip fuel the way an engine does. A chunk of enriched uranium releases an almost absurd amount of energy through fission, and it does it for years without being touched. The Nimitz-class carriers, the workhorses of the US fleet for decades, run on cores that last roughly 20 to 25 years before they need refueling. One refuel in the entire 50-year life of the ship. The newest carrier, the Gerald R. Ford, went even further. Its reactors were built to squeeze out about 25% more energy than the ones before them, enough to run the ship for over 25 years at a stretch. Submarines are arguably even more extreme. The earliest nuclear sub, the Nautilus, needed refueling after about 2 years. Modern submarine cores are designed to last the entire life of the boat, over 30 years, without a single refuel. The Navy's newest missile subs, the Columbia class, are being built around cores meant to run 40+ years. You launch the submarine, and you may never refuel it once before it's retired. You might be wondering why a nuclear core needs refueling at all if it lasts that long. And the answer is a little surprising. It doesn't run out of fuel the way a car does. What happens is that as the uranium splits, it leaves behind waste products, and some of those waste products are very good at soaking up the same neutrons that keep the reaction going. Xenon is the big one. Over years, that gunk builds up inside the fuel and slowly chokes the reaction until the core can't sustain itself anymore. It's less like an empty gas tank and more like a fire slowly smothering in its own ash. So even the reactor's eventual limit has nothing to do with sailing. It's just chemistry playing out over a couple of decades. And that's not just a spec sheet claim. In 1960, the US Navy decided to prove it in the most dramatic way possible. They took a submarine called the Triton and sent it around the world. Completely submerged. It followed roughly the same route Magellan sailed 4 centuries earlier, except Magellan needed almost 3 years and lost most of his men. The Triton did the loop in 60 days and 21 hours, never surfacing, covering more than 26,000 nautical miles underwater. The crew only broke the surface once, and only enough to hand off a sick sailor. The reactor didn't even blink. 4 years later, the Navy showed it wasn't just a submarine trick. 3 nuclear-powered surface ships, led by the carrier Enterprise, sailed all the way around the world in 65 days, without taking on a single drop of fuel or a single crate of supplies from anyone. They called it Operation Sea Orbit. 30,000 miles, no refueling, no resupply, no stops. So sit with that for a second. 60 years ago, we already had ships that could circle the entire planet without refueling. The fuel problem, the thing that limited every navy in human history, was basically solved before your grandparents were born. Which raises an obvious question. If the fuel can last for decades, why did the Triton still come home after 2 months? Why does any of them come home at all? The reactor clearly isn't the thing dragging them back to port. So we have to keep going down the list. The next problem sounds even harder than fuel. Right up until you see how they solved it. A ship full of people needs 2 things constantly, and neither of them is optional: fresh water to drink and air to breathe. You'd think being surrounded by an entire ocean would make water easy, but seawater will make you sicker faster than drinking nothing at all. And a sealed submarine hundreds of feet underwater has no window to crack open. Run out of either one, and the trip is over in days, not months. Except the reactor quietly fixes both. Start with water. That reactor produces an enormous amount of heat, far more than the ship needs just to move. So engineers use the leftover heat to boil seawater, catch the steam, and leave the salt behind. What condenses out the other end is clean, distilled fresh water. A big carrier can make hundreds of thousands of gallons of it a day, enough to run the showers, the laundry, the kitchens, and still have plenty to spare. On a submarine, that same trick means the crew basically never worries about running dry. The ocean they're floating in becomes their water supply. Air is the clever part. You take some of that fresh water and run electricity through it, which splits the water into hydrogen and oxygen. The hydrogen gets dumped overboard, and the oxygen gets fed back into the boat for the crew to breathe. So the submarine is literally manufacturing its own air out of seawater and reactor power. And to deal with the carbon dioxide everyone keeps exhaling, there are scrubbers packed with chemicals that pull the CO2 back out before it can build up to dangerous levels. Put it together and you get something that sounds like science fiction. A nuclear submarine can generate its own power, distill its own water, produce its own oxygen, and clean its own air, all from the reactor and the sea around it. Left alone, those systems could run for years. That's why submariners have a saying that stops people in their tracks. The boat can stay down longer than the crew can. The machinery isn't the weak link anymore. So we've knocked out fuel, and now we've knocked out water and air. 2 of the 4 walls gone. And yet they still come home. Which means the answer has to be one of the last 2 things on our list. This is where it stops being about engineering and starts being about something the reactor can't help with at all. Here's the wall nobody thinks about. Food. A reactor can split atoms for 30 years, but it cannot make a sandwich. Everything the crew eats has to be loaded onto the ship before it leaves, physically carried aboard and crammed into every spare inch of space. And a warship carries a lot of people. A big aircraft carrier can have more than 5,000 sailors on board. Feed that many people 3 meals a day, and you go through staggering amounts of food fast. So how much can they carry? On a submarine, the honest answer is about 90 days' worth, and that's if they get creative. Submariners will tell you they load the boat until there's food stacked in the passageways, in the shower stalls, under the bunks, anywhere a can will fit. Crews have literally walked on top of stacked food cases for the first week of a patrol, until they ate their way down to the floor. And even loaded to the ceiling, it doesn't last forever. Ask a submariner how a long patrol really ends, and you'll hear the same story again and again. The good stuff goes first. Then the fresh food runs out, the fruit and the vegetables, and anything that doesn't come in a can. By the tail end of a 90-day patrol, more than one sailor has described it plainly. You're down to bread and water. That's not a figure of speech. It's just what's left. This is the piece that trips people up. We solved infinite power. We solved water and air. But food is stubbornly finite, because it's just mass. There's no reactor trick that turns seawater into a steak. Whatever you didn't bring, you don't have. And you can't just build a bigger pantry to fix it. Space on a submarine is the single most fought-over thing on board. Every cubic foot you hand to a walk-in freezer is a cubic foot you took away from a torpedo or a bunk or a piece of equipment the boat needs to do its job. So the amount of food is capped not by what the crew could eat, but by what the designers were willing to give up to store it. And a ship that spends its cargo space on frozen chicken instead of weapons stops being a warship. That trade-off is quietly why the 3-month number holds decade after decade, no matter how good the technology gets everywhere else on the boat. Now, surface ships found a clever way around this, and it's worth understanding because it changes the picture. A carrier out on deployment doesn't touch land for months, but it isn't truly alone out there. Supply ships come alongside while both vessels are still moving, and they pass across food, spare parts, and jet fuel on cables strung between the 2 ships. It's called replenishment at sea, and it's one of the most nerve-wracking maneuvers in the entire Navy. 2 massive ships running side by side, close enough to hand things across in open ocean. That's how a carrier stays out for months without ever setting foot on a dock. It's getting groceries delivered at sea. But notice what that really means. The carrier isn't beating the food problem. It's just having the food problem solved by somebody else over and over every few days. A submarine hiding underwater on a nuclear patrol can't do that, because coming up to accept a delivery would defeat the entire point of hiding. For the sub, whatever's in the pantry when the hatch closes is all there will ever be. So food sets a hard ceiling, somewhere around 3 months for a boat that's truly on its own. That's a real answer, and it's a lot shorter than 30 years. But it's still not the final one, because even if you somehow packed enough food for a year, there's one more thing on the ship that would break long before the pantry did. And if you find that as satisfying as I do, the way the real limit is never the obvious one, consider subscribing so the next one finds you. Because this last wall is the strangest of them all. The people. You can engineer a reactor to run for decades. You cannot engineer a human being to be okay with living inside a steel tube for that long. And this turns out to be the real ceiling, the one every navy on Earth quietly designs around. Picture what a long submarine patrol actually feels like. There are no windows, ever. From the moment the boat submerges to the day it comes back up, the crew lives entirely under artificial light. No sunrise, no sunset, no weather, no horizon. Some boats fake a day-night cycle by dimming the lights on a schedule, but your body knows it's a trick. On top of that, the watch schedules are strange enough that a single day on some submarines can run 18 hours instead of 24, which quietly scrambles everyone's sense of time. Sailors describe how the days stop feeling like days and blur into one long stretch of the same fluorescent hallway. Then there's the space, or the lack of it. You're sharing a cramped, noisy metal environment with more than 100 other people, and you can't go anywhere. You can't step outside. You can't get a moment truly alone. And you can't just call home when you feel like it. Families can send short messages, sometimes only a few dozen words, and that thin thread is what connects a sailor to everyone they love for months at a time. None of that shows up on an engineering diagram, but it's exactly why patrols end when they do. The Navy doesn't bring a submarine home after 70 or 90 days because the reactor got tired. It brings the crew home because human beings have a limit, and pushing past that limit just makes mistakes more likely. On a nuclear submarine, mistakes are the one thing you truly cannot afford. And here's the proof that this ceiling is real, and that it's being tested right now. Modern aircraft carriers keep getting stuck at sea longer and longer, and when it happens, the reports aren't about the reactor. They're about the people. When one carrier recently spent well over 200 days at sea with almost no port stops, the concern coming off that ship wasn't fuel or machinery. It was morale. Sailors worn thin, families stretched, a crew running on empty long before the ship was. So that's the real hierarchy of limits. Fuel could last decades. Water and air effectively forever. Food about 3 months on your own. And the crew, the softest and most stubborn wall of all, is the one that actually decides when the ship turns around. Which finally lets us answer the question we started with. If you're asking how long a ship can physically stay at sea without touching land, the answer depends entirely on what you're really asking. If you mean how long the machine can run, the honest answer is measured in decades, because the reactor and the life support systems just don't care how much time passes. But that's never the number that matters, because there are always people on board. Once you put a crew inside, the ceiling drops hard. For a submarine truly on its own, unable to be resupplied without giving itself away, the real limit is food and human endurance, and that lands you somewhere around 3 months. That's why the Triton's trip around the world took 60 days and not 6 years. The reactor could have kept circling the planet. The people couldn't. Surface ships stretch it further by cheating a little, taking deliveries at sea so they never have to dock. That's how a carrier stays out for 200, even 300 days. But even that isn't the reactor's limit. It's the Navy pushing its sailors as far as it dares, and lately, a little further than that. So the next time you see a warship out on the horizon and wonder how long it could stay out there, remember that the steel and the reactor gave up being the limit a long time ago. We solved that problem back in 1960. What actually decides when a ship comes home is the same thing it always has been, all the way back to the wooden ships and the wind. It's the people on board, and how long they can last out there before the sea sends them home. What those long deployments really do to the sailors living through them, the toll it takes, and why the Navy keeps pushing anyway, is its own story. And it's the one I want to tell you next.